Example 1.4 is going to continue to look at the union and intersection operations with sets. But here we're going to be looking at infinite sets. So with the infinite sets, the best way to illustrate what's taking place is to use a number line. So with the number line, we're going to be looking at illustrating each infinite set individually and then assessing what does the operation do to these two sets. Are we looking at combining the sets together? Are we looking at the overlap of the two sets? It all depends on whether it's the union or the intersection. Looking at part A, I'm going to draw a number line, and this number line is going to be relatively long. And when I look at the first set, I see -3 to +4. And the second set is going to be from 5 to 7. We're looking for the union of these two sets, which means, from an illustration purpose, rather than thinking of these two sets as being individual sets, just think of it as being one big set on the number line. It just happens to have two pieces as part of its drawing. So what we see here is the answer. This is it. There's nothing more that needs to be done. Part B, however, is going to require us to do some simplifying once we get done with our drawing, and you'll see what I mean when I get to that. So let's go ahead and get on to part B. So for part B, I'm not going to need quite as big of a number line. I'm going to start it down here. Start from 0, 1, 2, 3, 4, and we'll just go to 5. All right, now the first set that I'm going to illustrate here in green is the open set bounded from 1 to 2. Just looks like that. Now the next set, let me get a different color. Let me use pink. This is going to go from 1.5 to +4, and this is closed on each end. Now I need to be sure to connect the two boundaries, and it looks like this. So if I take these two sets and I apply the union concept, the union means I'm supposed to be taking all of these elements and putting them together into one set. So if I was to take these two lines and merge them as one, I'm going to use red to represent that, and I'll do it just above the lines that we have here. It would look like this. Open at the left end, closed at the right end, and because I have overlap right here, that means that I can get away with representing every single real number in between 1 and 4. So what we have here in red represents the simplified union of these two sets. So we can write that this union is equal to 1 to 4. Open on the left, closed on the right. Let's do the same thing for part C. So with part C, I need a number line. Put 0 in the middle this time. And if I look at the first set, this is an infinite set, but it is not bounded on the left. So I'll put an open circle at -1, and we'll draw all the real numbers going to the left. But it's interesting here because the second set also uses -1. They both use -1, but this time -1 is the left boundary where it's open, and there is not going to be a right boundary. It's going to be headed toward positive infinity. So I'm going to leave the open circle where it is, but I'm just going to start here on the right and continue on in this direction. So it looks like this. So I want to make a note here that we have a symbol which is going to be the double bar R. This is equal to all real numbers. That means the entire number line. Now the way that we represent the entire number line using interval notation is by doing this, -infinity to infinity. Now that implies that there is no gap. There's no hole in the numbers. There's nothing missing. All of the real numbers are there, every single one of them. But that's not what we have with our picture. Our picture does have an arrow going to the left, which is headed toward -infinity, and it has an arrow going to the right, which is headed toward positive infinity. But we are missing one value. We're missing the value of -1. So that means that this is not equivalent to all real numbers. It's close. It's almost all of the real numbers. It's all of the real numbers except for -1. So there is no better way to write the set that we have here. Just leave this set as it is. You don't have to simplify it. It's fine. Part D is going to be pretty similar to this. Part D is going to give us two sets. One of them is going to be from -infinity to 4, and the other is going to be from 4 to infinity. So once again, we're using 4 in both of the sets, but we're using it as a right boundary for one set and then a left boundary for the other set. From the number line perspective, it's going to look very similar to what we did on part C. So I will put a open circle at 4. I need everything to the left of 4 for the first set, everything to the right of 4 for the second set. So we have all real numbers except for 4. There it is. Now I want you to look at part E and compare it to what we have with part D. And you should see that there's only one difference. And that one difference is right here. It's closed. Now what that means is that we are supposed to include 4. So I want to draw this and give you a chance to see how these two sets are going to come together. The number line that I'm going to set up will look just like the one that I set up for part D. Start at -1. Now this time I'm going to start with the second set, the 4 to infinity. So I'm going to put an open circle at 4, and I'm going to move to the right. Let me get pink, and I'm going to use this pink one to now illustrate the first set. And the first set is actually going to be closed at 4, and it's going to go to the left. So notice that it looks very similar to what we had with part D, except the hole has been filled in at 4. So the equivalent set for these two sets being unioned together is going to be all of the real numbers. So because we allowed 4 to be a part of one of the two sets, that means we no longer have that hole, and ultimately this means that our union is equivalent to all real numbers. Let's take a look at part F. On part F, I have 3 infinite sets with 2 operations. Now, it doesn't say anything here about having any grouping symbols, nothing like that's going on, so I'm just going to work this thing from left to right. I'm going to make my number line. There's 0. My first set will have an open point at -2, everything to the left of -2. My second set is bounded on the left and the right at -2 as well as at 0. So I'm going to put an open circle at 0 and I'll mark everything in between. And then the third set is going to be unbounded on the right, and it's going to start at 0, going from 0 to infinity. So now we have something that's very similar to part C and part D, except we have 2 holes in the graph instead of just 1. So this means we have all real numbers except for -2 and 0. All right, 3 more examples left. Those were the examples that were all union related. These next 3 examples are going to be intersection related. So for the intersection, we're going to be looking at the same perspective. We're going to take each set, draw them individually, and then we're going to check to see is there any kind of overlap between the 2 sets, and then that overlap ends up being what our final result is for the intersection of the 2 sets. So let me go ahead and draw a number line. And we'll get some different colors here. Let's stick with green for the moment. -infinity to 5, closed at 5, everything to the left. -infinity to 3, let me get my pink pen out. -infinity to 3, that's going to be closed at 3, and then everything to the left. So the intersection is not wanting all of the elements. It only wants the elements that these 2 sets share in common, and that's known as the overlap. So the overlap I'm going to draw in red is going to be all the real numbers up to +3. Everything that's less than +3, including +3. So that means that I can more simply write the intersection as being equivalent to -infinity to 3. Do the same thing for part H. With part H, we have 2 sets again, looking for the intersection. First set, open at -3, everything to the left. My second set is going to be open at -5, and it's going to want everything to the right. So again, what I'm looking for is the places where we have overlap. So at -5, I have an opening for the second set, but I have it closed on the first set. So I'm not going to be able to include -5. And the same story goes for -3. I can't include -3 because -3 is not a member of both sets. But there is overlap between the green and the pink line everywhere in between -5 and -3. So I'll mark that as the final result there for this intersection, which means that I can take the intersection statement and I can write it more simply as -5 to -3. Always writing it from left to right. And our last example is a trivial example, but I think it's fun to go over anyway. One of the sets is -infinity to infinity. Remember, we said that this is the same as saying all real numbers. So I'm going to take all real numbers. Let's go ahead and get some values on this number line. All real numbers would be everything from left to right. Everything. All the real numbers. That's it. But my second set is only from 4 to infinity. So it looks like I need to extend this a bit. We'll make this 4 and 5. We'll extend this a little bit longer too. And 4, I'm going to have an open circle here at 4, and I want everything to the right of that. So if I look at the overlap is going to be identical to the second set. So the overlap is just going to be from 4 to infinity. So that's how I can more simply write this particular intersection.